Okay, team, this is an extended version of 3C. So for this situation, we already did A and B. We had this initial equation, which it was the cumulative distribution, and we found this equation here, which was the probability distribution. Okay, so to find the mean or the expected value, we want to run an integral from the whole domain, and notice the difference here. We have r squared here, we have r to the third here. Remember that when you're doing expected value, you multiply by, in this case, r, could be x, whatever your variable is, so that you can gauge the distance from, if we remember, we talked about the fulcrum idea. This is your weight, and then you also need the extra r to tell you the distance from the fulcrum. Excuse me. Okay, so now we have this situation. We have a product that we want to integrate. This is a good candidate for integration by parts. So if you think of the I late, this is an A, and this is an E. So we'd want this to be our U. So we have our U here, we have our dV here, so we find V and we find du. We took out the r, then we put our pieces together. We have r cubed, that's u, v, minus the integral of v du. Okay. But you'll notice that this integral again has the same situation where we have this product, so we're going to do the same thing again. So we keep this. This is just kind of rewritten to look a little more clear. We have our 4 out front. It's to everything. We brought this. We have a negative. We have a half here, and we have a 3. So we made positive 3 halves. And now we have this situation. So now our new u is going to be r squared. Our dv is still the same, and so we have these pieces again. So we're bringing down. All this stuff was just what we had before. Then we're dealing with this integral, integration by parts. So we have our u, we have our v, we have minus v du. Okay. And the 3 halves is out front, so it goes to everything. Then you'll see again we have the same situation. We have our r here, we have our r in the exponent here, so we have a product again that we have to deal with. So we're going to do integration by parts again. We're keeping all these pieces just how they were, and now we've simplified a little. We brought our negative half out here. Here we had a negative, and we had a half and a 2, so we've simplified that. Now our u is r, and same situation here. We have our v, our dv. Remember, because we're choosing dv to be this part in here, we have this negative 1/2 for the v that needs to come out front. So then we put that piece in. All of this is just the same as it was, and now we're getting to this integration part. Integration by parts, so we have u, v, minus v du. Okay, so now we're close. Some of you are able to do this just straight away. I went ahead and said u substitution for this, so u substitution, put that piece in, then I have all of this now. I have all of that I've had for the whole time. I'm just keeping track of all my pieces here and do my u substitution. So then when I take the integral of eu, I just get eu again. I took out this negative 1/2. That's why we have a positive 1/2, negative 1/2. That's why we have a 1/4 here. I integrated eu, and I got eu, and then I substituted back in for my r's. So I had that part. Now I have all this put together, and remember that it's not, I've been using indefinite integrals, but I actually have limits of integration from 0 to infinity. Now this is just the simplified version. I distributed everything out. This 3/2 goes to all these pieces, and this 4 goes to everything. So I get this situation here. So one of the hardest things here is just keeping everything straight. Okay. Now that we have this situation, if I want to use infinity as one of my limits, then really I'm taking, or sorry, as the limit of integration, really I'm taking the limit of some value as it goes to infinity. So here I use b just because it was the top. And so the limit as b goes to infinity, and now I'm evaluating, I put b in for the infinity, and then zeros in here, so I got b's everywhere. As you can see, I have an e to the negative 2r in all of my terms, so I brought that out. So e to the negative 2b, all these pieces, then minus, now I'm dealing with all the same thing except putting in zeros, so I put in zeros everywhere. Okay. Okay. So now we'll simplify this a little bit. E to the negative 2 times 0 is e to the 0, which is 1. So I have 1 times whatever I get out of here. These three terms go to 0. Then I have 3/2 here, negative 3/2. So negative 1 times negative 3/2. So I have this here. Remember that this e has already been dealt with, so it's not part of that. That's why I accidentally put parentheses around this, but those are scribbled out. Okay, so now I have this situation here. Now what I did to the next step is just dealt with this negative exponent by bringing the e to the negative 2b to the denominator, making it e to the positive 2b. And now I'm dealing with a limit. I've got this piece over here that's constant. Just to kind of make it easier to see, I multiplied by 1 over b cubed over 1 over b cubed. That's just a fancy 1, so it doesn't change the value. And then when I distribute that through, I get this on top, and then I get this in the denominator. Okay, so you can see from here, as this goes into infinity, this fraction is going to be 0, that fraction is going to be 0, that fraction is going to be 0, and I'm going to have negative 2 here. Okay, so then we really want to look at what's happening in the denominator. So I'm looking at the limit as these two go to infinity. Well, that's infinity over infinity. So I can use L'Hopital's rule. So I take the derivative, and I get here, I still have infinity over infinity. I take the derivative again, I still have infinity over infinity. And then when I take the derivative one last time, I have something going to infinity over a constant. So then that whole fraction is going to infinity. Now this fraction was the denominator here, so I had negative 2 in the numerator, and then a denominator going to infinity. So that whole fraction then is going to 0. So 0 plus 3/2, so 3/2 is my mean. So if we look at our curve, this curve in red here is the distribution, probability distribution, and 1 is what we found for our mode, the most likely. You can see that that's where it reaches the top. And we just found 3/2. This is the mean. That means the expected value. If I put a fulcrum here, then this whole, if we took the area under this curve, it would balance. That's different from, this is an approximation. It's not. It's just a tiny bit more than 4/3. But this is the line of the median, or approximately. It's actually quite complicated to calculate in this particular situation. But that means 50% of the curve is on this side of that red line, and 50% on this side of the red line. And notice that the mean is actually a bit to the right of the median, and that's because the mass over here is kind of bunched up. It's skewed left, so your median is going to be left of your your mean. And we'll just add that back in, and then your mode here. Okay. So hopefully that was helpful. Again, you can look back through, and I'll link to this document so you can take a look at the steps more carefully. But that's the long process to solving that question.